Usually when we talk about technology updating, it feels, well, a lot like getting a fresh coat of paint on a house.
Right, just a cosmetic thing.
Yeah, exactly. Your phone gets a little faster,
Right.
or the screen gets a little sharper. Maybe the camera lenses shift around a bit on the back.
You adapt pretty quickly. It's an entirely surface level stuff.
Right. And it's comfortable. We generally like to feel that the foundation of our daily lives is, solid and predictable.
Absolutely. Incremental change is safe.
But then you hit a moment in time where someone isn't just painting the house. They are literally ripping out the foundation, rewiring the walls, and replacing the roof while you are, still sitting on the living room couch.
That's a great way to put it.
And welcome to August 2026, everyone. Thank you for joining us for this deep dive. The shift we are living through right now isn't incremental, it is seismic.
It absolutely is. We are crossing a threshold where technology is no longer just a tool we pick up and put down.
Right.
It is actively becoming the environment we inhabit. And the stakes for understanding this landscape, they're just incredibly high right now.
So today we are unpacking a really definitive source document. It's called Top 17 New Technology Trends That Will Define 2026. And our mission for this deep dive is to synthesize all this information so you don't get overwhelmed.
Because there's a lot to cover. And these sources aren't just projecting a list of, cool new gadgets you might buy for the holidays.
Definitely not.
What we are looking at is a projected automation of up to 70% of everyday work tasks.
Wow. Up to 70%.
Yes. Let that sink in for a second. 70% of the routine, cognitive, and physical tasks that currently make up human labor are being fundamentally restructured.
Okay, let's unpack this. Because 70% sounds terrifying until you realize exactly how it's happening.
Right.
And it really starts with how we actually build the digital tools we use. We're looking at a world where software is suddenly doing the heavy lifting of, writing software.
Exactly. The source material notes that over 75% of new applications are now being created using low-code and no-code platforms.
So we're talking about systems like Glide and Bubble.
Yeah, Glide, Bubble, Microsoft Power Apps, and Google's AppSheet. Historically, if you wanted to build an app to solve a problem, you needed to speak a completely different language.
Like Python or C++ or something.
Right. You had to be a software engineer, or you had to pay one a lot of money to do it for you.
Yeah, you essentially had to hire a human translator to sit between human logic and machine logic.
Exactly.
But now it's like having a master sous chef in the kitchen. You don't need to know how to precisely julienne the carrots at blinding speed or, debone a chicken perfectly.
But just write the menu.
Right. You drag and drop the ingredients you want, and the software cooks the meal. And when you add in generative AI, things like GPT-5 and Gemini Ultra, which are just the default baseline, now you can literally just tell the computer what you want in plain English.
And it goes significantly further than that, actually, with autonomous AI agents.
Oh.
The data highlights systems like Devin. Devin doesn't just wait for your drag-and-drop commands or act like a glorified autocomplete. It operates autonomously.
Wait, autonomous in what way?
It has its own command line, its own code editor, and its own browser. You give Devin an objective, and it breaks that objective down into steps. It writes the code, tests it, finds its own bugs, fixes them, and deploys the website.
That's insane.
It can even handle the back-and-forth client communication without any human intervention.
So it's basically a full-stack developer in a box.
Precisely.
Right.
And we are also seeing this at the foundational level with AI native operating systems.
Like Microsoft rolling out Copilot in Windows 11.
Yeah, and the new macOS updates, AI is so deeply embedded into the architecture of the system that you don't even have to switch apps anymore.
Because it just knows what you're doing, right?
Right. The operating system itself understands the context of what you are trying to do. If you are looking at a financial spreadsheet and open an email draft, the OS already anticipates you want to summarize those numbers.
And it just pulls the data directly into your draft for you.
Exactly.
But let me push back on this a little bit.
Sure.
If AI is building the apps, writing the text, generating the images with things like Adobe Firefly, and managing the workflow entirely on its own, aren't we just generating an infinite sea of digital noise?
How do you mean?
Well, if anyone can make a functioning app in 5 minutes, doesn't that just guarantee we are going to be flooded with a million terrible, useless apps?
Well, if we connect this to the bigger picture, the core value isn't found in the sheer volume of apps in an app store.
Okay.
The value is in the hyper-democratization of problem solving. Think about the long tail of software. Large tech companies only build software for massive markets because, well, that's where the money is.
Right, they need scale.
But what about a nurse who sees a massive, specific inefficiency in their specific hospital scheduling system?
Oh, I see where you're going with this.
Or a special education teacher who needs a highly customized interactive tool for just one neurodivergent student?
Before, they were completely locked out.
Exactly. They were locked out of creating a solution because they couldn't code and couldn't afford a developer. Now they can build the exact bespoke tool they need over a weekend.
So it shifts the human role away from the mundane execution of, like, typing syntax.
And it elevates us to high-level strategic direction. We become the architects of solutions rather than the bricklayers.
The human becomes the strategist, not the typist. I love it.
It's a massive shift in human potential.
But practically speaking, that creates a massive logistical and infrastructure headache, doesn't it?
In terms of processing.
Yeah. If software is doing all this heavy autonomous thinking, anticipating our needs, and creating bespoke tools for every individual person on the planet, where is all that sensitive, intimate data going?
That is the big question.
Because we can't possibly rely solely on the cloud for that level of constant second-by-second processing.
You've hit on the exact physical limitation of the previous tech era.
Yeah.
The old model was that your device was essentially a dumb terminal. It gathered your request, sent it over the internet to a massive server farm in a desert somewhere. The cloud did the heavy thinking and sent the answer back.
Which was fine for, like, loading a web page.
But with the sheer volume of AI tasks happening in 2026, relying on the cloud breaks down for two main reasons: latency and privacy.
Because of the delay.
Right. Latency is the time that round trip takes. When your operating system is trying to anticipate your next keystroke, a half-second delay to a server in Nevada is just an eternity.
Here's where it gets really interesting, I think. Because the solution to that bottleneck is Edge AI.
Yes, Edge AI is changing everything.
We are seeing chips like Apple's A17 Pro and M4 series, or Intel's Meteor Lake, completely rewriting the rules by putting the processing power directly on the local device.
Right onto the hardware in your hand.
The way I like to think about it is this. The old cloud model was like keeping your deeply personal diary in a public storage unit across town.
That's a great visual.
You had to drive in traffic there every single time you wanted to read a page. And you just had to trust that the security guard on duty was actually paying attention.
Which isn't always a given.
Exactly. Edge AI is like keeping that diary in a biometric vault right inside your own living room.
That's a perfect analogy for the mechanics of it. And it's driven heavily by regulation, actually, not just convenience.
Like the privacy laws.
Yeah, with strict data protection laws like GDPR in Europe and CCPA in California levying massive fines for data mishandling, companies are essentially forced to adopt privacy-first AI.
So they don't want the liability of holding your data on their servers anyway.
Exactly. Models like Meta's Llama 3 are specifically optimized to run locally. Your voice recognition, your real-time language translation, summarizing your private meeting notes, it all happens instantly on your device's neural processing unit, or NPU.
And the data never even leaves your hand.
Never. And because the NPU is dedicated solely to AI tasks, it doesn't drain your battery in 10 minutes like it used to.
But wait, let's look at the other extreme here. Can a tiny chip on my phone really compete with massive cloud servers for the really big stuff?
Well, no.
Because Edge AI sounds great for sorting my emails or translating a conversation, but if we are trying to cure complex diseases or manage global supply chains, my phone isn't going to cut it.
You're absolutely right, and that's why computing architecture is actively diverging into two very distinct paths right now.
Okay, so a split approach.
Yes. For everyday, localized tasks, latency and privacy win out. That's Edge AI. But for universe-level complexities, we're moving entirely away from classical computing and toward quantum computing.
Ah, quantum computing. The source notes that companies like IBM are bringing quantum computing into commercial utility right now for these massive calculations, right?
Yes, it's finally moving out of the purely theoretical phase.
Right, but you know, quantum is one of those buzzwords that often just sounds like science fiction to people.
It definitely gets overused in movies.
What actually makes it different from just a really, really fast regular supercomputer?
It comes down to the fundamental mechanism of how they solve problems. A regular computer, even a massive supercomputer, processes information sequentially.
One thing at a time.
Right. If you imagine trying to find your way out of a complex maze, a classical computer tries one path, hits a dead end, backs up, and tries the next path.
Okay, so it does this incredibly fast, but it's still just one path at a time.
Exactly. A quantum computer uses qubits, which can exist in a state of superposition, meaning they represent multiple states simultaneously.
So it's walking down every single path in the maze at the exact same time.
That's exactly it. So when you apply that to, say, pharmaceuticals, a classical computer tries to simulate how a chemical compound interacts with a protein by testing combinations one by one.
Which takes years.
But a quantum computer can simulate millions of molecular combinations and folding patterns simultaneously. It reduces drug discovery timelines from a decade of trial and error down to just months.
That is unbelievable.
Or it can optimize a global shipping network with millions of moving variables in real time, instantly calculating the most efficient route if a storm shuts down a major port.
Okay, so the causal link here is just fascinating.
How so?
Because we now have localized, instant, and private processing power on tiny chips in our pockets, combined with quantum-heavy lifters in the background, technology fundamentally no longer needs to be tethered to a physical desk.
It's completely untethered.
It is breaking out of our flat glass screens and mapping directly onto our physical environment.
Right. We are seeing the massive convergence of spatial computing, IoT, the Internet of Things, and robotics.
It's all bleeding together.
It really is. It's about digital intelligence integrating seamlessly with physical spaces. Let's start with AR, or augmented reality glasses. Companies like Apple and Meta are pushing these past the novelty phase.
Yeah, the sources say they're becoming viable replacements for traditional screens entirely.
Exactly.
I have to say, the idea of AR glasses acting as universal subtitles for real life is wild.
It's a game changer for accessibility and communication.
The source talks about walking into a meeting and having your talking points literally hovering in your field of vision, or talking to someone speaking Mandarin and seeing the English translation instantly floating below them.
Like movie subtitles in real time.
Yeah. But I'm inherently skeptical. I mean, I know how the internet works.
Oh, I see where you're going.
Are we going to be completely overwhelmed by pop-up ads and data in our actual field of vision? I really don't want a holographic spam email for car insurance blocking my view of oncoming traffic while I'm just trying to cross the street.
It's a completely valid fear, and frankly, it's the dystopian scenario every hardware manufacturer is trying to avoid right now.
I hope so.
We will absolutely see the rise of ad block for your eyeballs as a premium software category. But your concern actually pivots us to the broader shift.
Which is?
This raises an important question, not just about what data you were looking at, but how our environments are designed to look back at us.
Right.
We are entering the era of IoT 2.0.
The Internet of Things.
Yes. We are talking about an ecosystem of 30 billion connected devices globally. The document gives incredible, large-scale examples of this in action.
Like what they're doing in Singapore.
Exactly. Singapore isn't just using pre-programmed timers for traffic lights anymore. They are using AI to analyze real-time camera and sensor data to dynamically adjust traffic flow and reduce congestion.
And South Korea is doing something similar, right?
Yes. South Korea is installing smart poles across cities that actively monitor air quality, provide public Wi-Fi, and even charge autonomous vehicles.
So the environment isn't static anymore. It's like the city itself is waking up and paying attention to the people moving through it.
It's highly responsive.
And it's not just the static environment, it's the physical workforce operating within it.
Yes, the automation of labor.
We know workflow automation tools like ServiceNow, UiPath, and Zapier are already operating in the background, reducing repetitive digital administrative tasks by 65%.
Which is massive on its own.
But the truly wild part of this physical mapping is the robotics.
Yes, the commercial viability of humanoid robots and AI-enhanced logistics. We aren't just talking about a little automated vacuum bumping into your couch anymore.
Right, like an old Roomba.
We are seeing companies like Agility Robotics and Walmart using autonomous scanners that navigate incredibly busy, unpredictable retail stores using real-time spatial mapping.
But the major historic leap has to be humanoid robots.
Absolutely. Companies like Figure AI partnering with BMW to put humanoid robots directly onto manufacturing floors.
And Amazon rolling out Astro to patrol homes and assist with elder care. I just imagine a robot silently judging me for leaving my shoes in the middle of the hallway.
They probably have data on your shoe habits by now.
But seriously, it's a total shift in how machines interact with us physically.
It is a fundamental inversion of labor dynamics. For a century, physical automation meant stationary machines doing single, repetitive motions.
Like a robotic arm welding a car door on an assembly line.
Exactly. Humans had to completely conform to the machine's strict, highly controlled environment. If a human stepped out of line, the machine broke, or someone got seriously hurt.
Because the machine was blind.
Right. But now, because of that edge AI we talked about and a mechanism called sensor fusion.
Wait, sensor fusion?
Yes. Sensor fusion is the process where a robot takes continuous data from multiple sources, optical cameras, radar, acoustic sensors, and LiDAR, and fuses it together in real time.
To build a picture of the room.
To build a rich 3D understanding of context, not just pixels. Because of this, the machines can now conform to the human environment.
Oh, wow.
Humanoid robots can navigate stairs, recognize that a dropped box is an unpredictable obstacle rather than a permanent wall, and perform tasks requiring nuanced dexterity.
So the nature of physical work is changing forever.
It's becoming a fluid collaboration between humans, smart IoT environments, and commercial robotics.
So, if technology has learned to perfectly navigate and integrate with our external physical world, from dynamic traffic lights to humanoid coworkers, the absolute final frontier has to be navigating our internal physical world.
You mean biology?
Yeah, our bodies, our biology, and our minds.
And that covers the massive leaps in personalized healthcare, advanced wearables, and brain-computer interfaces, or BCIs.
The progression outlined in the sources here is just fascinating to me.
It's moving so quickly.
Because, like a decade ago, we started with basic wearables that essentially just counted our steps.
Very basic pedometers, essentially.
But by 2026, devices from Aura, Whoop, and integrated smart rings are continuously monitoring blood oxygen levels, tracking minute changes in heart rate variability, and detecting physiological stress or viral onset days before you even feel a physical symptom.
Which completely shifts our approach to health.
So what does this all mean for us? It means we've moved past the novelty of hitting 10,000 steps. Wearables have essentially become a real-time telemetry dashboard.
Like in a car.
Yeah, exactly like what you'd see in a Formula One race car, but for the human body. The pit crew knows the tire is losing pressure before the driver even feels a vibration on the steering wheel.
That telemetry analogy is spot on. We've moved from external fitness tracking to internal AI diagnostics.
Which brings us to the DeepMind research.
Yes. The source highlights incredible work from Google DeepMind, which can now identify multiple systemic diseases just from a routine retinal scan.
Just by looking at your eye, how does that even work?
Well, the retina is actually the only place in the human body where you can directly and non-invasively observe the microvascular system.
Oh, because it's completely exposed.
Exactly. DeepMind's AI analyzes the microscopic blood vessels in your eye, and by cross-referencing millions of data points, it can detect the early markers of cardiovascular disease, diabetes, and hypertension.
That's incredible.
It's predicting health risks across your entire body just from a quick scan. And on the treatment side, AI is moving us away from a one-size-fits-all approach entirely.
Especially with something as complex as cancer treatment.
Precisely. By parsing thousands of genetic variables against massive databases of chemical compounds, AI can now tailor chemotherapy regimens to a patient's exact genetic and molecular makeup.
So it's predicting exactly how a specific tumor will react to a specific chemical.
Yes, down to the molecular level.
It's incredibly hopeful. It's precision medicine finally realized. But, the document also goes into something that feels straight out of a cyberpunk novel.
The brain-computer interfaces.
Yeah. Neuralink and similar companies moving from experimental trials to actual real-world applications.
Yes, the transition to direct neural integration. We're talking about physical implants that read the electrical signals of your brain and translate those intentions directly into digital commands.
And reading those signals has always been the impossible hurdle, right?
Yeah.
Because the brain is so complex.
Absolutely. For decades, reading brainwaves through the skull was like sitting outside a massive baseball stadium, trying to figure out exactly what pitches were being thrown just by listening to the muffled roar of the crowd.
You could guess the general mood, but you had no details.
Exactly. Neuralink and these new BCIs are essentially like putting a highly sensitive microphone directly on the pitcher, the catcher, and the umpire.
Wow.
Initially, the profound application here is for individuals with severe mobility or communication challenges. It's about restoring the ability to operate a robotic limb, control a wheelchair, or type on a screen simply by thinking about the action.
Simply by thought. You completely bypass the hands, you bypass the vocal cords, and you go straight from pure intention to digital action.
It's a medical miracle, really.
But the source material explicitly calls out the massive privacy implications here, which is something we definitely have to acknowledge. We have to look at this impartially.
It is arguably the defining question of the next decade.
Yeah.
When you create a direct two-way bridge between a human brain and the internet, the questions of consent and potential misuse are just staggering.
Because it goes both ways.
If your thoughts can instantly control a connected device, can a compromised device influence your thoughts?
That is terrifying. Who legally owns your neural data?
Exactly. How do you protect a brain-computer interface from a cyber attack? We have regulations like GDPR for our emails, as we saw earlier with Edge AI.
But neural privacy is an entirely new frontier of human rights.
Society, lawmakers, and ethicists are scrambling to define this right now.
It really makes you pause and take a breath. We've covered an unbelievable amount of ground today.
We really have.
We started with the democratization of code, where anyone, a teacher, a nurse, can build complex software just by giving instructions to an autonomous AI agent.
Changing how we build things.
We explored how the sheer weight of that data pushed processing out of the cloud and into the biometric vaults of Edge AI, while quantum chips tackled the universe-level simulations.
It's hardware revolution.
Then we saw technology escape the screen, mapping onto our physical reality through spatial computing and humanoid robots that can actually understand their surroundings.
The integration into our physical spaces.
And finally, we look at how AI is merging with our biology, from real-time health telemetry to the breathtaking frontier of direct neural interfaces.
It's a comprehensive map of a world in rapid, unprecedented transition.
And the most important takeaway for you listening is that this future isn't just happening to you.
Right. You are an active participant.
By understanding the underlying mechanics of this roadmap, you are armed with the tools to shape your own career, protect your own privacy, and design your own life.
Exactly.
You don't have to just sit on a couch while the foundation of the house is replaced. You actually have the tools to help draw the blueprints.
I think that's exactly the right mindset to have. But I do want to leave you with one final, slightly provocative thought to mull over, building on everything we've just discussed today.
Okay, let's hear it.
We noted that the source projects AI automating 70% of routine tasks, and that BCIs and AR are moving toward retrieving information at the absolute speed of thought. If your glasses or a neural implant can instantly retrieve any piece of information, a historical fact, a complex mathematical formula, or a real-time translation, what happens to human memory?
Oh, wow.
Will our physical brains neurologically adapt to no longer store facts, but simply learn how to navigate the endless flow of information? Are we on the verge of outsourcing our memory entirely?
Man, that is a profound question. If the foundation of the house shifts that much, does the concept of the house even mean the same thing anymore?
It's something we'll all have to figure out.
That's going to stick with me. What do you think about these technology trends? Which one excites you the most? Let us know in the comments below. Don't forget to like and subscribe for more insightful content on the future of technology.